Welcome to the video demonstration of the OSCORE profile of ACE framework test suite within the F-Interop platform. This video is brought to you by the University of Montenegro and the SPOTS team. You can find more details about the SPOTS project at spots.ac.me. The ACE framework under standardization in IETF-ACE specifies the use of OAuth2 three-party authorization protocol for constrained environments. The framework can be instantiated with different web transfer and security communication protocols such as HTTP or CoAP, TLS or OSCORE. OSCORE profile instantiates the ACE framework for use with CoAP and OSCORE. The OAuth or ACE architecture assumes the presence of three entities: a resource server hosting a given protected resource, a client interested in obtaining representation of the protected resource hosted by the resource server, authorization server, a trusted third party that issues access tokens needed by the client to access a protected resource on the resource server. Before a client can request a token and obtain a representation of the protected resource, a couple of assumptions need to be met. First, the authorization server and the client share a pre-established OSCORE security context, allowing them to mutually authenticate and to communicate securely. In addition, authorization server and the resource server share a cryptographic key. This key is used by the authorization server to encrypt the token when sending it to the client. The fact that the token is encrypted on the application layer allows the client to present this token to the resource server securely, even when the underlying transport session is not encrypted. When a resource server receives, decrypts, and validates that the token indeed comes from the authorization server, it can install a dynamic OSCORE security context with the client. The resource server then allows the access to the protected resource over this OSCORE secure channel. In this demo, we will test step C of this protocol exchange, where the client sends the access token to the resource server to install the new security context with it. The three roles from the previous slide have been implemented in different projects of the OpenWSN environment. OpenWSN is a project founded at UC Berkeley, now led by INRIA, that implements the 6-ish protocol stack. We will use this implementation as the implementation under test. The ACE framework has been mapped to a 6-ish use case as follows. The authorization server is co-located with a 6-ish entity called Joint Registrar Coordinator, or JRC, that is in charge of managing the network join process. The role of the ACE authorization server has therefore been mapped within the OpenWSN software project and implemented in Python. The resource server is co-located with a constrained 6-ish node. The role of resource server has been implemented within the OpenWSN firmware project and in embedded C. Finally, the role of a client has been implemented as a generic CoAP application that can run anywhere on the internet. The code of the ACE client is contributed to the OpenWSN CoAP project and is written in Python. This slide illustrates the architecture of the F-Interop platform and the 6-ish testing tool. The user sitting in a remote location connects to the F-Interop platform through a web-based graphical interface. The user selects a test it wants to run and connects IoT devices it wants to test to its machine. A sniffer that is local to the user is used to capture the packets exchanged over the radio. This captured trace is sent to the F-Interop testing tool component running in the cloud. The testing tool uses Wireshark to dissect the packets and verify conformance as specified by individual test cases. We will use the implementation under test, or the OpenWSN project, in emulation mode and sniff the packets that are exchanged in the emulated network. The actual test we will run covers the client sending the access token to the resource server. The client obtains this access token from the authorization server in a previous step and forwards it to the resource server. You can see the technical details of this test on the right. Only if all the steps of the test pass and the automated checks of F-Interop, the final verdict issued is a pass. I will now proceed to the demonstration. From the F-Interop graphical interface, I will select the test ACE OSCORE 02 that we will run. The goal of this test is to cover the exchange where client sends the access token to the resource server for validation. The first prompt asks for the name of the companies that are executing the test. Since this is a compliance test, I will enter University of Montenegro in both fields and submit. The following prompt asks for the IPv6 addresses of the entities participating in the test. The default values of client IPv6 and resource server IPv6 addresses are the correct ones and are those that are used by the implementation under test in simulation mode. I will confirm the default values and proceed. The configuration step of the test is launch, where it is indicated that the client uses the access token obtained from a previous step. To obtain the access token, I will now launch the implementation under test in simulation mode with 2 nodes in the network. This will start the authorization server as well as 6-dish network. I will set the first node to act as the border router. Which will trigger the formation of the network, and where the second node will act as the resource server. Now we will wait for the network to form, and we see the second node joining, and once it sends a DAO message, it becomes reachable over the internet. Now I will trigger the client to request the access token. The application prompts whether the client should request the access token. I will say yes, and we'll wait with the following response. I will now return to the F-Interop graphical interface and submit that the configuration is considered valid, since the client application now has the access token. The next prompt is on pre-test conditions, where we need to verify that the resource server is switched on, which we have just done when launching OpenWSN in simulation mode, and that Wireshark is capturing packets. I will start Wireshark on the TON interface, where the simulated packets are exchanged. Once I do that, I go back to the F-Interop graphical interface and proceed. This prompt now asks for the actual stimulus of the test case, which corresponds to the client sending the access token to the resource server. So I will respond with yes, and which will trigger the client to send the access token to the resource server. Once I do that, I go back to the F-Interop graphical interface and submit. The following prompt requests the packet capture to be uploaded to F-Interop. I will switch to Wireshark, stop the packet capture, and export it. I will only export the co-op packets in order to shorten the processing time of F-Interop. I will now go back to the F-Interop graphical interface and select the trace that we just saved from Wireshark and upload it to F-Interop. Now the test execution begins on F-Interop side, and the packet trace is processed for compliance with the specification. we can see that all the steps passed and that the verdict issued by the F-Interop platform is a pass. This confirms that the implementation of the OSCORE profile of FACE framework within the OpenWSM project is compliant with the standard specification. Thank you for following this demo. Please check out the other demonstrations that were provided as part of the SPOTS project.